All right, IM3 classes. Today we are wrapping up our factoring lessons. We're going to learn one more method of factoring called factor by grouping, and then we are going to combine the different methods all into a single factoring problem. So let's talk about factoring by grouping. So what we're going to see is polynomials that have more than 3 terms. All right, they're going to have 4 terms. Typically, the degree is going to be 3. Sometimes be higher, and we'll get into what to do with that. But for right now, what we're going to do is called factor by grouping. And the first step to factor by grouping is to group, make 2 groups out of polynomials. So the grouping part comes into grouping the first 2 terms and the last 2 terms. It's important to double check to make sure the polynomial is written in the correct order. So decreasing exponents, 3, 2, 1, 0. All right, from here, all right, you're going to treat each of these as individual factoring problems. You're going to factor out a greatest common factor. Greatest common factor between 12n cubed and 2n squared is 2n squared. When I factor that out, there'll be a 6n plus 1. So remember, the greatest common factor is just reverse distributing. So if we were to distribute the 2n squared back, we would get 12n cubed plus 2n squared. Next, greatest common factor between 18n and 3 is 3. So I can factor out of 3 and I get 18n plus, not 18n, 6n plus 1. What I want you to notice at this point right here, 6n plus 1, 6n plus 1. Those should match at this point. If they don't match, it doesn't factor. All right, they have to match at this point. All right, so what you're going to do is you're going to then, again with grouping, you're going to group the outside terms together. So 2n squared plus 3 get grouped together in its own binomial. So those are going to come down here. So that becomes 2n squared plus 3. And then 6n plus 1. It's multiplied by the one that's together. And there we go. That is our answer. So what we're doing is undoing multiplication. All right. So if we were to multiply this, go backwards, remember you can split and distribute. So what we're doing is figuring out what that split is and bringing it back together. All right. Let's look at another example. Careful on this one with the negatives. So I'm going to group the first 2 terms. Just to make life easier, I'm going to make this plus a minus 42 and then group these last 2 terms. So this middle sign here is negative, make it plus a negative and then group that negative in with the second 2 terms. All right. Greatest common factor between 6m cubed and m squared is m squared. So then I'm left with 6m minus 1. Greatest common factor between negative 42m and 7. When this is negative, what you want to do is factor out a negative. So I'm going to factor out a negative 7. And this becomes a positive 6m minus 1. So now these match. So it's going to be m squared plus negative 7, or just minus 7, times 6m minus 1. So again, these are getting grouped together and then multiply by the binomial. All right. Oh, wrong button. Let's do another example. All right. Group the first 2 terms, last 2 terms, first 2. There we go. What's the greatest common factor between 6x cubed and 2n squared? That's going to be 2, not n, x squared. And I'm left with 3x plus 1. Greatest common factor between 21x and 7 is 7. I'm left with 3x plus 1. Now regroup the terms on the outside. So 2x plus 7, 2x squared plus 7, and then 3x plus 1. All right. Another one, make sure. So this is a middle term, make it plus a minus. So I'm going to group these together. Then these together. So greatest common factor between 6p cubed and negative 14p squared. That's going to be 2p squared. What's left would be 3p minus 7. Here, greatest common factor between negative 3p and 21 is going to be negative 3. Then I'm left with 3p minus 7. Group outside terms together, so 2p squared minus 3, and then 3p minus 7. All right, so the next thing we need to talk about is factoring completely. So sometimes there's more than one layer of factoring. So when I'm talking about, let's say if we were going to factor a number, so something like 30. So 30 factors into 2 and 15, and 15 factors again into 3 times 5. 30 has 2 layers of factoring, has 3 total factors. That's what's going to happen with these problems here. There's going to be multiple layers of factoring, right? It's going to be more than just 2. So we're going to have to combine everything that we've learned so far about factors. We have 16x to the fourth minus 81. So 16x to the fourth and 81, those are perfect squares. This starts off as a difference of squares. So square root of the first is going to be 4x squared plus or minus square root of 81 is 9. So this first layer of factoring came down here. But this here, this factors again. This is also a perfect square. So I need to factor this. So 4x squared minus 9, that's a difference of squares again. So square root of the first term is 2x. I can make a better parenthesis there. Plus or minus square root of the last term is 3. So we have 2 layers of factoring. So the total factors is going to be 4x squared plus 9. And then 2x plus 3 times 2x minus 3 are all the factors. I shouldn't cross that out, but let's look at another example. 4t to the 6th minus 20t to the 4th plus 24t squared. So need to double check for greatest common factors. So 4t to the 6th, 20t to the 4th, and 24. Those are all, so the numbers are all multiples of 4. So I can pull out a 4 from this. This could be 4. And then t to the 6th, t to the 4th, t squared. I can pull out a t squared from all that. So then what I'll have left is t to the 4th minus 5t squared plus 6. So again, we are reverse distributing. From here, gotta check to see if this factors. That will be an x factor problem, 3 terms. So 6 on top, negative 5 on bottom. What are factors of 6 to add to negative 5? That's going to be negative 3 and negative 2. So this has one more layer of factoring, which is t, since it's t to the 4th, be careful with that. It's t squared minus 3, and then t squared minus 2. So 4t squared. Check to see if any of these are, oh yeah, bring that down. Check to see if any of these are different squares there or not. So we are done here. So it has that 2 layers of factors. Right. Let's do another example. 16 x cubed minus 44x squared minus 42x. The first layer of factoring, I can factor out a, these are all even. You can factor out a 2 in all of those, and they all have an x, so the lowest one, x. So when I get that, it's going to be 8x squared minus 22x minus 21. All right, so from there, that is an x factor problem. So on top, it's going to be 8 times 21 is negative or it's a negative 21, so negative 168, then negative 22. This one might be a little tough. Let's see, 168 divided by 16. Nope. I'm just doing some double guess and check. 168 divided by, it's not gonna be 20, is it? No, 168 divided by 32. No. 68. Yeah, this one's tough. 168 divided by, there we go, 168 divided by 28. So it's going to be 28 and 6. So negative 28 plus positive 6. That was a tough one. So here's the part we need to divide by the 8. Don't divide by the 2. That's one of the most common mistakes. We are going to divide by the 8. So this reduces to 3/4. This reduces to negative 28. That's going to be negative 7/2. And then now factor to 2x minus 7, 4x plus 3 will be the final factor. Ooh. All right. So this is just a normal X factor problem. So negative 60 on top, negative 4 on bottom, but it factors negative 60 that add to 4, negative 4. That's going to be negative 10, positive 6. So here, this is, since it's an n to the 4th, that's going to be n squared minus 10, and then n squared plus 6. Check to see if there's any difference of squares, and there's not, so we are done with that right there. So last one we're going to do. So negative 5x cubed plus 320. The 320 and the 5, as a factor, so I can factor out a negative 5 on that. I'm left with x cubed minus divided by 5 is 64. So here, so this is our first layer of factoring. Here, this is a difference of cubes. So remember, I'm going to identify my A is X, my B is 4. And then the 2, it's going to be a binomial. Give a little bit more space. And a trinomial. So it's going to be A squared. So same. So remember, so same, opposite, always positive. So same, opposite, always positive. So we got to fill in here. So, and then it's going to be B squared. No, sorry. A minus B. And then it's A squared plus A times B plus B squared is 16. All right. And there we go. Don't forget the last factor. That is it. So we're going to end it there. Let me know if you have any questions. Other than that, we'll see you guys next time.